This is Accelerated Geometry, Section 4.1. The topic is Triangle Sum Conjecture. So I have pictures here of some triangles. On the left are a picture of the Louvre. In the center, in Egypt, the pyramids. And on the right-hand side, the Calatrava Museum of Art in Milwaukee. One thing that they do bring up in this section right away is that triangles have a property of stability. So in this first shelving unit on the left, they say that that is not very rigid. If I put stuff on there, that could fall. To make it more rigid, if I put a piece of wood in the back there and nail it on, because I have a triangle in there, the triangle will add stability or rigidity to that figure. Another application of triangles is a procedure called triangulation, and you use this in surveying. This procedure allows surveyors to locate points or positions on a map by measuring angles and distances and creating a network of triangles. Triangulation is based on an important property of plane geometry that you will discover in this lesson. Next, if you are in class, you will have an investigation to do, and in class I will explain it to you. If you are not in class, you might want to just pause this video now and do the investigation on page 204 to 205, steps 1 through 5. At the end of it, you should be able to write a conjecture that explains what you have discovered. In the meantime, what I'm going to do is go to this video, and I'm going to play this. And what this is our author of our textbook, Michael Serra. He is actually talking people through the investigation or investigations that you will be doing in the textbook. So what he's saying here is we have 3 different triangles, different shapes. If you are in a group, everybody would draw 1 or 2 of these triangles, all of different shapes. And the first thing that we would ask you to do in the investigation is to measure the angles in your triangle. So here he is taking a protractor, and he is measuring that angle to be 74 degrees. He takes his protractor again, measures angle number 2, and he finds out that that is 49 degrees. And then he has one more angle left, angle 3. So the 3 angles in the triangle will now all have measurements on them, 57 degrees. Then what he does is he adds them all up and he gets 180 degrees. So if you were doing this in a group and you did 1 or 2 triangles like this and everybody else did 1 or 2 triangles, you would find out that in general, if you add up the sum of the 3 angles in any triangle, no matter what shape or size, the sum of the 3 angles would always be 180 degrees. And then he said, okay, here's another way to see the exact same thing. So here's a triangle, and instead of measuring the angles, we're just going to label them, A, B, and C. And now he's going to cut the triangle, so all the sides are nice and sharp. And then he's going to take his fingers here, his hands, and he's just going to rip off the angles. So there he is ripping off angle A, there he is ripping off angle B, and there is angle C. And now he's going to place them on a straight line. He's going to pick a point, and he's going to say, okay, that's 180 degrees. A straight line is 180 degrees. He's going to put a little glue there to help these pieces stay better. And he's going to take angle A. He's going to put it along that line with the vertex of angle A at that point. And now he's going to pick up B and put it next to angle A. And then he has left angle C, which, ta-da, fits in perfectly. And this is now the second way to see that the three angles in a triangle always add up to be 180 degrees. Now he's going back here to this problem, and he's saying that was 180 degrees when we did it the first way, and when we did the second investigation, we get the exact same answer, even though in the second way of doing it, we didn't even have to worry about numbers. All we had to worry about is that a line is 180 degrees. Now he's going to kind of mix the two methods together. And he's saying that these three angles add up to be 180 degrees. We've seen it two different ways. So here was the second method again, just to remind you. He likes to remind you of things over and over. And now he takes patty paper, paper that you can see through. It's kind of, you can see that it's pretty thin paper. And he's going to call those A, B, and C. So those are the measurements of those angles inside that triangle. And now he's going to take some more patty paper, and he's going to trace that angle A. So he's lining it up, and he's going to mark that that is A. Then he's going to pick up the patty paper and slide it over, and now next to A, he's going to draw in angle B, and then you can guess what he's going to do next. He's going to put in angle C. And again, this is kind of the combination of all methods here. You can see that the three angles of a triangle, again, add up to be 180 degrees. So now I'm going to see if I can get out of this and go back to our lesson for today. And this says after we have done the investigations, you can look at what the conjecture should be. So here is conjecture number 17, which you should be adding to your conjecture list. The sum of the measures of the angles in every triangle is 180 degrees. And there is a picture to go along with it, a sketch that you always need to include on your conjecture list also. So I think that is the end of this lesson.